Assalamu alaikum and good afternoon everyone. This is topic 4, the last topic that covered in the first course learning outcome for my part. Please answer the tutorial questions and upload your answers in Spectrum. I will see you virtually on 19 of April 2021, to discuss the answer for tutorial 1 and to brief on the summative assessment. On this slide, it outlined the topic to discuss today. To the general public, liquid crystals are often primarily known through their electro-optic applications in displays, light shutters, or optical light modulators. Lyotropics are generally quite unheard of, despite of the fact that we use them on a daily basis. On the slide shows the applications of lyotropic liquid crystals based on the classification of the mesogens. The first type of mesogen that we'll discuss is the amphiphilic. Amphiphilic surfactants are used in soaps and detergents. This is the major industry and whole world use huge volume of it. Soaps and detergents have molecules with one side that prefers water, hydrophilic, and another side that prefers oils and fats, hydrophobic. The hydrophilic side attaches to water molecules, and the hydrophobic side attaches to oil or dirt molecules. This action allows the oil droplets to break up into smaller droplets, surrounded by water. These smaller droplets are no longer stuck to the material to be cleaned, and are washed away. In crude oil industry, surfactants are used for oil recovery. When an oil well dries up, it still contains up to 50% of the original oil, but is trapped in porous rocks. Surfactant flooding is a multi-component multi-phase system, and can improve oil recovery by injecting a solution of surfactant. This method of surfactant-enhanced oil recovery recovers the residual oil saturation by reducing interfacial tension between oil and water phases. In food industries, amphiphilic surfactants are used as emulsifiers. Some detergents and surfactants are used as emulsifying agents. An emulsifier keeps oil droplets and water droplets from joining together, so a thick mixture of oil and water will not separate. This is to maintain texture, color, flavor, and viscosity. And encapsulation of unfavorable aroma, flavor, nutrient, vitamins, mineral for taste and color masking. Examples of emulsions are mayonnaise, butter, cream, homogenized milk, and salad dressings. Overall, its course: improvement of mouthfeel, increase melting tolerance, improving heat shock tolerance, and appealing texture. In pharmaceutical industry, amphiphilic surfactants can be used as drug carrier. Lamellar phase can form vesicles as synthetic ionic or non-ionic surfactants or liposomes, based on natural phospholipids. Hydrophilic drugs can be placed in the cavity, while the hydrophobic drug can be encapsulated in the hydrophobic bilayer. Besides the lamellar phase, cubic phase also can be used as drug carrier. Drug carrier that exhibit cubic phase is called cubosomes. Look at the picture on the slide for the illustration. The drug carrier that is in hexagonal phase is called hexosomes. Amphiphilic surfactants also used in liquid crystal templating. Example is MCM41, mesoporous silica, used in heterogeneous catalysis, and of most interest is the introduction of transition metals into the mesoporous silicas. The mechanism is as shown on the slide. It can be used in either gaseous or liquid reactions. An easy phase separation once the reaction is complete. There are more applications based on amphiphilic surfactants. But the last application that I will provide is the application in protein crystallization. Self-assembly can nucleate crystal growth. The patchy nature of protein interactions thus greatly facilitates their self-assembly, which then guides the subsequent crystal morphology, as illustrated on the slide. Now, we see some of the applications based on chromonic surfactants. The first one is the fabrication of oriented films. Evaporation of solvent from the aligned liquid crystals films gives solid films in which the orientational order of the dichroic mesogens is retained. These liquid crystalline and solid films have useful properties as linear polarizers, optical compensators, retarders, alignment layers, and color filters. The second application is micro-patterned polarizing elements and photo-induced liquid crystalline gratings. This is used as holographic films, as viewing angle-dependent optical materials and in 3D stereoscopic displays. Without the solution, ribbon-like chromonic liquid crystals develop in random directions. The solution of chromonic mesogen is placed on the microfeatures substrate and let the solvent to evaporate. The chromonic liquid crystals is developed along the direction of the substrate. When the solvent evaporated and the microfeatures substrate is dried, then can peel of the microfeatures substrate. The micropattern can be collected. The last application for chromonic surfactants that we will discuss is the application of chromonic as biosensors. In biosensors, polyaniline, PA that exhibits nematic liquid crystals can be used to detect virus existence. The polyaniline shows a nematic phase in the presence of viruses. Look at the images on the slide. We can observe the nematic phase in image in the middle. This is rapid technique in detecting grip viruses. But, need to premix the analytes with the chromonic liquid crystals before assembling the liquid crystals cell and interference from large spherical contaminants and particulates. The last mesogen that we discuss is cholesteric surfactant. Lyotropic films may possess some advantages in biological studies as many biological materials which exist in liquid crystal phase are lyotropic. To template the electrochemical deposition of mesoporous crystalline oxide semiconductor films, fabricate mesoporous crystalline oxide semiconductors.